Hey there, Mr. Wilford here. I just wanted to go through Chapter 7, Section 5 with you. And this is all about using proportional relationships. We've been working quite a bit now with similar polygons and similar triangles and doing a little application, different properties and theorems that way. Now what we want to do is take a look at doing some indirect measurement. And basically what that is when we use proportions to measure things that are difficult to measure. Basically, indirect measurement is any method that uses formulas, similar figures, and or proportions to measure an object. And so if something is too big or too small to actually measure easily, we can do this sort of proportional relationship. And here's an example where we are taking a look at two triangles, and this is where we can utilize some things because we're dealing with two right triangles, and they're similar triangles. What we can do is we can make some small measurements here that are easy to measure, and then we can use that similarity idea, the proportion idea, to measure something that's quite large. So the first part here is they're really just converting measurements into inches so that we're talking about the same units, and they all are in terms of inches, both triangles. And then we are taking a look here at similar triangles because we have a couple of angles that are the same, so we know they're similar triangles. We're measuring the shadows of each, and then we're really just putting this into the proportion, taking AC, the measurement of the height here, comparing that to DF, which is the big height here, is equal to BC, which is easily measured here on the ground, as well as EF, which again is easily measured. And then it's just doing the cross multiplication, and we can find out that we have 280 inches is the height of this giant pineapple, or 23 feet and 4 inches. So these are some good application problems to take a look at as well. And we can take a look then at something called a scale drawing, and this represents an object as smaller than or larger than its actual size. And really, whenever you look at a map or anything like that, you really have a drawing scale so that you know exactly what the scale is. So this distance here on this map would represent 300 meters. Here it says a scale drawing of the map downtown Dallas is 1.5 centimeters to 300 meters. And so we use that in our proportion, and we can cross multiply as we go. Here's another example that you can take a look at, making a scale drawing. And again, we're dealing with proportions here and cross multiplication. And going on here, we have a couple other ideas here. Similar triangles. We have similar triangles. Really, we have all these things happening, and so this is maybe a good thing to kind of jot down in your notes. Similarity ratio, and you can see the comparisons of the sides. Perimeter ratio, and now we're talking about the distances around each of the triangles. Has to do with the perimeter. And the area ratio, now we're talking about the area inside each of these triangles. You can see how they're compared. Then we have theorem 751, proportional perimeters and areas theorem. And what this is saying is, if the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is A over B, and the ratio of their areas is A squared over B squared. And so you can see here that we are, when we look at two similar figures, we have a lot of comparisons that we can make and go between in terms of perimeter and areas. Here's an example to take a look at as well. As always, if you have any questions, please let me know. Thanks.